Okay, so calculating mass percent composition. Essentially, what you are doing here is working out what percentage of the entire mass of the solution each solute component corresponds to. Now, based on the amount of mass, you cannot say which is the solvent, which is the solute, because remember the definition of solute and solvent goes on the major molar component being the solvent, and the minor molar components are the solutes. So unless you go ahead and work out the moles of each, you don't know for sure which one the solvent is. So first of all, the total mass of the solution is what you're going to have to work out. So that's going to be all the components added together. So in this case, it's going to be 63 grams of the carbon tetrachloride, the 72 grams of the thiopene, and the 67 grams of the 2-ethyl toluene. So from a Gen Chem perspective, I would probably expect you to be able to know the chemical formula of carbon tetrachloride. Thiopene and 2-ethyl toluene, you don't even know at this stage how to work out what the chemical formula is and therefore the molar mass and stuff. So you wouldn't be able to calculate molar percentages, but mass percents we can. So 63 plus 72 plus 67 would give me 202 grams. So to calculate the percent by mass of each of these components, we're just going to take the mass of the component divided by the total mass of the solution and times 100 to convert to a percentage. So my mass percent of my carbon tetrachloride will be my mass of my carbon tetrachloride, which was 63 grams, divided by the total mass of the entire solution, which is 202 grams, and then multiply that by 100 to convert that to a percentage. So that will come out to be, excuse me one second, 63 divided by 202, 31.88, blah, 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 31.8, say one more, blah, 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 whatever that is. Okay, looking at these numbers, we should only be given our answers to 2 sig figs, and in fact, the question asks us to give it to 2 sigs. So I'm going to give it to 2 sigs, so that would be 31, if I could type 31% by mass. All right, let's tidy this up a little bit, like so. All right, so then we can work out the mass percent for the other components. And of course, all 3 components should add up to 100%. So mass percent of the thiopene will be the mass of the thiopene, like so. So that was 72 grams divided by the mass of the total solution, so 202 grams. Then times that by 100 to convert that into a percent. So let's work out what that will be. 72 divided by 202 times 100 will be 35.6435, blah, 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 blah. So the 2 sig figs, that's going to be 36%. All right. Then lastly, we need to do the mass percent of the 2-ethyl toluene. So we're just going to take the mass of the 2-ethyl toluene. So that is going to be the 67 grams divided by the total mass of the solution, which is 202 grams, and multiply by 100 to convert to a percent. And we want to give that to 2 sig figs. 67, so that's going to be 33.1683, blah, 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 blah. So 33% to 2 sig figs is sufficient for that. Okay, so from mass percentages, you cannot determine what is a solvent, what is a solute, etc., because remember those come from the relative amount of moles. And from this question, I wouldn't expect you to be able to calculate the relative amount of moles because you don't have the formulas, and at Gen Chem kind of level of understanding from those particular names, I wouldn't expect you to get the formulas apart from for carbon tetrachloride, which of course be CCl4.